So as you know that we have discussed, functions are of two types, predefined and user defined. The main aspects, the key aspects of a function. Function contains three parts: function definition, function call, and function declaration. Defining a function, declaring a function, and calling that function. Okay, first you need to declare, after that define, after that call. Okay, or you can write first you declare, after that call, after that define. Okay, the basic syntax for function, declaration, and all of them are: for declaration, whatever the return type and the function name. Return type is nothing but you have void, main, void, int, etc. And the function name, whatever the name you want, arguments list. Okay, it contains set of arguments. For function call, just you need to write the name of the function and whatever the arguments, the actual arguments you want to pass, you can write here. And the function definition, return type, function name, and the arguments list. Remember, definition in the sense you need to write some meaning of that function, nothing but the defining part of that function. That's why we have opened the braces here, open and closed, inside that the body of the function, nothing but what is the key of that function, what is the use of that function is being written inside. Remember that function contains three main aspects: function definition, function call, and function declaration. You can check an example program here. This is int add, arguments are int x and int y. Okay, function name is add, and this is a return type. Int is a return type, function name, and parameters or arguments inside it. This is called as what? This is called as function definition because you are having braces. You can check here, right? Return type and having braces. This is what? Function definition. So the definition is int sum equal to whatever the arguments you have given, add them and return that sum. Okay. So why we have written here return sum? Because whenever the function definition is written, there might be some function call. So that function call must contain a value. That function call must contain a value. So how will that function call will get the value? Using this return statement. Using the definition of a function, the value is being written to the caller function. Okay, that is the use of this return statement. Again, I am telling what is the use of this return statement is you will have two aspects: function definition and function call. So when you call a function, that function must have or hold some value. That value will be returned by this function definition. Okay, that is the use of this function definition and call. And you will be having declaration. Declaration is also important, very important, and you can check part by part. Function definitions, it is the actual function, it is the main function where the code will execute. Okay, and remember it must be identical to the function prototype. Whatever the header you have given, it must be identical. You can check that return type, function name, and arguments, declarations or statements or return types, whatever you want, you can give inside them. That is about functions. And let us get into another topic, that is about variable scope and lifetime. Scope of a variable and lifetime of a variable. Scope is nothing but it refers to that part of a program that may refer to the variable. Okay, a variable which is valid till which part of a program. Scope is nothing but the scope of a variable is nothing but the variable which is valid till which part of the program. Till which part of the program. What is lifetime? Lifetime is nothing but the time in which the variable stays in the memory, the time at which the variable long lasts in the memory. You can tell like that. Okay, lifetime, in the name itself, the time of a variable at which in the memory at which it long lasts. Okay, or you can say the time in which a variable occupies a place in memory. Scope and lifetime are determined by how and where the variable is defined. This is very important. How the variable is defined and where that variable is defined depends on it. Types of scope, you can check function declaration, local scope and global scope. Lifetime also you can have local and global. What is local, what is global? In the name itself, local is nothing but it is valid, or its access level is up to that block, specified block. Local is nothing but what? It is valid, or its accessibility is only within that block. Global is nothing but its accessibility is throughout the block, or throughout the program, not block, throughout the program, or throughout the code which you have written, throughout the main method, you can tell it like that. Okay, that is the difference between local and global, which are very important terms. And the storage classes in C, it is also one of the most important and prominent concept in C. There are 4 storage classes: auto, extern, static and register. So storage classes, what are the locations, declaration locations, and its perspective, scope and lifetimes. Okay, first auto. Remember, auto is inside a function or block. Auto, register and static you need to write inside a block or a function, whereas static global is outside all functions and extern is also outside all functions. Extern and static global are outside all functions, nothing but inside in that code. It is valid in that code. It is not mandatory to have inside till that block. Okay, only auto, register and static local are declared inside a function or blocks. What is the scope and lifetime for it? Scope is nothing but visibility, and lifetime is till which time they are alive, or till what time they are alive. Okay, auto, within the function or block it is alive. Okay, it is visible, not alive, and its lifetime is until that block completes or until that function completes. These both are almost same, within that block and until that function completes. And register also same, within that block and until the function or block completes. And static local you can check within that block and until the program terminates. Until the program terminates. So you need to remember these 3 are very important. These 3, extern, static local, static global, have the lifetime until the program terminates. Extern, static and static local and static global have the lifetime until the program terminates. And the scopes, right? For static local, it is similar to register and auto. The scope is within the functional block. Extern, the scope is entire file plus other files where the variables is declared as extern. Suppose, let us take there are 2 files. In the first file you have declared extern, so the scope is there in that first file where you have declared extern, and also in some other file where you have declared extern as well. Suppose if you have written extern in other file also, there also the extern keyword is valid. And similarly for static global, it is only entire file in which it is declared. Static global, in the name itself global, till that file where you have declared. This is the scope, visibility, scope, lifetime, and where you need to declare the storage classes. Okay, this is very important. And recursion, let us look into the new concept. What is recursion? Recursion is nothing but, you can check from this code. There is a function called int recursion of x. Inside that you have if statement, and you have written something called as recursion of x minus 1. Nothing but your function name and your function call. This is function call, right? Function name brackets is nothing but function call. So this is function call. Function call and function name. Inside the function definition, you have function call. Generally, what we will do in the main method, we will call the function so that it moves into the function definition and finds for that computation of values. But here, inside the function definition, we are writing the function call, nothing but function calling itself. This is nothing but function calling again itself. This is called as recursion. Okay. And remember, there is a base case and function call. So two parts, base condition and recursive function call. Recursion, you need to remember there is a base condition and there is a recursive function call. These both are very important. You can check a function calling itself is called as a recursion. It performs the task by dividing it into subtasks. Okay, nothing but if you want a sum of first 5 numbers, let us take, right, if you want sum of first 5 numbers, first it will check for 1, after that for 2, after that for 3, after that for 4, till 5. That's it, right? That is the meaning of recursion. It is dividing into a subtask. Suppose if you want factorial is the best example of recursion. If we take 5, right, 5, if we decrement or if we subgroup it, you will be getting 4, and after that 3, after that 2. So each term gets multiplied over it, right? Over it. That is the best example of your recursion. And let us learn the termination condition. There is a termination condition or a base condition. Okay, define the function satisfied by some specific subtask where the recursion stops. Okay, that is the base condition where the recursion will stop, and the final result will be returned to the function call. Okay, the case at which the function doesn't recur is called the base case. That's it, right? If you have defined base case and there is no recursion, then that is called what? Function that is called as a base case. Whereas the instances where the function keeps calling itself to perform a specific task, then that is called as a recursive case. And all the recursive functions can be written using that format. Okay. Now let us learn the differences between recursion and iteration. You might be getting a doubt, right? What is the difference between recursion and iteration? In iteration, you won't have any functions, and recursion, you have functions and function calls. What is recursion? Method of calling a function within the same function. And what is a loop? A control statement or a control structure that allows executing a code repeatedly within the program. Okay, within the same function within the program. Okay, and remember, recursion execution is slower and loop execution is faster. Loop execution is faster. What is the use of it? Stack. Basically, in recursion, we use a stack to store the local variables when the function is called. Whereas in loop, the stack is not used. It is directly calling the statements, right, by incrementing. Then also, if there is no termination condition, okay, then what happens? It leads to an infinite recursion. If the condition never becomes false, then it leads to what? Infinite loop. That's it, right? If the condition goes on true, then it moves as a infinite loop. If there is no termination condition, then it will become as what? Infinite recursion. And you can check recursion is more readable, whereas loop is less readable. And also talking about space complexities, recursion obviously stack, it is taking more space for each and every local to store the local variables when the function is called again and again. So the space complexity for recursion is higher, and for loop it is lower. This is about the differences between recursion and loop. And let us quickly look on with the functions programs. First program. Remember, in functions, as we said that there are different parameter passing techniques. Nothing but arguments. The arguments which we have, right? We have different passing techniques. You can call by value or you can call by reference. What is call by value? We have two types of parameters, actual parameters and formal parameters. Actual parameters are nothing but the parameters which we use in the function definition. Okay. Formal parameters or the dummy parameters are nothing but which we use in the function declaration. Okay. While declaring, we give some different or just like an example like parameters. But in the main definition, main function definition, there will be the actual parameters. So what is this call by value is whatever the change is done on the formal parameters, okay, will not affect the actual parameters. If you do any change on the formal parameters, it will not affect the actual parameters. Nothing but the same parameters will be passed on to this. Call by reference. Reference nothing but for different parameters there is different reference or different address. So whatever the changes we will be doing on the formal parameters will affect the actual parameters. This is the difference between call by value and call by reference. Let us look in with a simple example, right? And also this is about the functions. This is a void swap int a comma int b function definition. Okay, swap function name is swap, and before swapping I have given something, and after swapping this is swapping without any external variable. Okay, within those variables, within the given variables we are doing the swapping, and after swapping we are printing those variables. And this is the main method. In the main method we have given x and y, and this a and b are formal parameters and this x and y are the main parameters, the actual parameters. Okay, and here we are printing those actual parameters and swap of x comma y. This is what this is function call. So you can get over all definition, function call, declaration, definition here itself. So swap x comma y. So here you will be getting those values, and that particular operations whatever are there will be performed to print your swapped value. After function call, whatever happened is being printed here. Let us compile it and run. You can check. Before function call x10 y20. Okay. Before function call, what is there? Before function call x10 y20. Swap of x comma y. What happens? Swap of 10 comma 20. So it has moved into here. Here also swap of 10 comma 20. So the same variables are being printed, and after this operation exchanging or swapping is happened, and 20 comma 10 is being printed. After that what happens? It comes here after function call. So after function call x and y, what are x and y after function call? So the parameters are 10 and 20 itself. So whatever you have given here, the same parameters are being printed here. But what we have done here, we have interchanged those two numbers, but those interchange numbers are not printed here. So the changes happen to the formal parameters has not affected the actual parameters. This is the proof of it. Okay, this is about swapping. Okay, just we are writing different print statements, whether whatever x and y, if you want to print x and y, it is valid to this block only. Those values are being printed. We have changed them to a comma b. Now a comma b is being printed here, but here the exchange values are not printed. This is about parameter passing techniques. Okay, next, factorial recursion. Here comes the main things wherever you can learn about functions. This is function declaration, where you are writing int fact on fact recursion. This is function name and a simple argument as int. Okay, and inside the main function, this is the main function. Okay, you have result, and then result is nothing but the result of a number of a number, doing applying factorial. Scanf statement where you are scanning that number. Let us take input 5 and result equal to fact of n. So what happens? This is a function call. So it moves into the, whenever a function is being called, it moves into the function definition. It checks for the function definition in the program. There is a function definition which is there with braces, curly braces, where it takes the argument as capital N. Okay, and if n is equal to 1, return 1. That's it, right? If you want 1 factorial, then simply you return 1. No need to do recursion. Else case, we are not writing any else case. Simply we are writing, if it is not 1, return n star fact recursion of n minus 1. Nothing but this is recursive function call. This is recursive function call. Nothing but calling again the same function, just decrementing by 1. Nothing but what? You want factorial. Factorial is nothing but factorial of 5 is nothing but 5 into 5. No, 5 into 4. Nothing but the value must be decremented by 1. So that's why I have used here n minus 1. N star factorial n minus 1. 5 star factorial recurse of 4. Again it goes here. Okay. Factor recurse of 4. Again it comes here. For 4 again 4 star fact of 3. So again 3 star fact of 2. 2 star fact of 1 in that way. So finally we're getting 5 star, 4 star, 3 star, 2 star, 1. Okay. Factorial part result will be displayed in the output. And this is an iterative approach. We have discussed it in the earlier. Just I have given here. Let us execute it. Okay. If I want 5 factorial, it is 120. It's true. Let us check some other number. I want for 6. It is 720. It is also true. Simple. 3 things are important: function declaration, function call, and function definition. And inside function definition, we are using recursion. That's why I have used return n star factor fact recursion. So inside a function, calling that function again. Okay, that is a recursion. You can check similarly for GCD recursion also. Okay, for GCD of 2 numbers, we are taking n1 and n2, and simply we are saying that here is the definition which you need to look on. If the second number is 0, then you simply return the first number as GCD. Okay, or simply return the first number as GCD, else return n2 comma n1 mod n2. So this is a logic which you need to understand. Suppose if you want 3 and 6, okay, so this condition is false, right? So return 6 comma 3 modulo 6. Nothing but return 6 comma 3 modulo 6 is nothing but what? Same number, right? Okay, so in that way the recursion will be happen. Return again. So again for this 6 and 3 again. Okay, in that way till this condition reaches, the recursion will be happening. And in this case, I think you will be getting here 3 comma 6 mod 3. Okay, 6 mod 3 is nothing but 0. So n2 is 0. So n2 is 0 is nothing but 3 is your n1. So return n1, that is your GCD. That's it. Okay, this is GCD where you need to know what logic you need to apply inside the recursive function to get GCD. This is about GCD. Here you can check printf scanf 2 numbers, and inside the printf only I am placing my function call. This is what function call. Finally, let us end up with sum of n natural numbers. It is very simple, similar to factorial, but you need to do plus. Okay, the number whatever you have given plus decrement the number by 1, and for that number you add this number. Sum of let us take, right, 6. Here you will be getting 6 plus 6 minus 1 is 5. So output is 6 plus 6 minus it is sum natural of sum underscore natural of what? 5. So this is a functional call again. So again it goes into, it finds for this value. Okay, so what it will do, 5 plus 5 plus sum underscore natural of 4. Again what happens? 4 plus sum underscore natural of 3. So in this way, right, it will be doing. So sum of natural plus 5 is nothing but 5 plus sum of natural of 4. That's it, right? And what is sum of natural of 4? 4 plus sum of natural of 5. So similarly, sum of natural for 3 is nothing but 3 plus sum of natural of 2. And what is sum of natural of 2? Simple. 2 plus sum of natural of 1. What is sum of natural of 1? 1 plus sum of natural of 0. So decrementing, right? N minus 1. Sum of natural of 0. So you got n is equal to 0. N is 0. Nothing but written 0. So here you will be getting 0. So what is the answer for it? 6 plus 5 plus 4 plus 3 plus 2 plus 1. 3, 6, 10, 15, 21. This is your output. So let us run this program. Let us check for 6. We can check 21. This is your output. So what is the code? Let us check it once again. A number is defined, taking the input for that number. Remember, first is function declaration, giving a dummy variable, and inside the main function you are writing your, not main method, you are writing a function call inside your main function. You will be having n, and this is the input statement to take that n, and inside this printf statement only we are giving function call sum underscore natural of n, nothing but 5. So it will check for the function definition. Yes, the function definition is here, and this function definition will be executed again and again. Okay, like this, and it will print till it reaches the base condition. Return 0 is nothing but that's it. It returns whatever the addition you have got here is been returned into this function call, and that is been printed. That is only you can see in the output. Okay, once again I'll do it. Sum of n natural numbers is 21. Sum of n natural numbers. Okay, this is about recursion and functions.